So I was asked to present and talk about Snowball Edge. So we've got a couple different interesting things going on with Snowball as a product within AWS. And so I'd like to share those stories with you and kind of really my goal here and hope is that when we finish this session that I've planted some seeds for the art of the possible. What are some of the things that you could think about doing and using AWS at the edge? I'm Paul Bockelman, a specialist solutions architect. And before we get started, one of the things I want to do is I want to kind of set the stage with a little bit of history about Snowball and Snowball Edge. So why the need to go to Edge for computing. So I'm going to frame it in a couple of different problem statements. So the first problem was we needed to move, customers needed a way to move a lot of data into the cloud and a lot of data, be able to take data out of the cloud as well. Sometimes pushing or pulling it across a wire just wasn't really an option. And so back in the early days of AWS, we had a service called import-export. And I don't know if anybody here is familiar with that or ever knew about what that service was, but essentially what it was is a way for customers to be able to ship hard drives full of their data encrypted into an AWS region. The data would then be ingested and then the drives returned back to the customer. Not a scalable solution, not something that has a very good long-term life on that. So what we have done is, in 2015, Snowball, the first generation was introduced. And so we're using a standardized, secure container that can be shipped. Customer orders it, same methods, and I'll get into specifics about how we use that. Next problem statement is now that we had a way to actually move a lot of data around, there became a need for customers to be able to do some immediate processing, low latency processing at the point of ingestion. So before it was, we have a lot of data perhaps on our local network and we want to move it into the cloud. Then customers started using the Snowball as a solution for collecting large amounts of data because there's a fair amount of storage available to them. And they wanted to be able to start doing some pre-processing. And so the compute version of Snowball, the Snowball Edge, was introduced later, which had some capabilities on board, which allowed customers to be able to configure Lambda functions to run within Greengrass or something along that lines, and be able to start pre-processing data at the point of ingestion. And so, as the evolution continued, customers needed to do a little bit more than just running functions, running Lambda functions or transformation functions. Customers start asking for, well, we need to be able to operate our own workloads. We need to run them in a disconnected fashion. We may or may not have network. So we need to be able to take our workloads that we're running either in our data centers or in the cloud, and we need to be able to bring those out to the edge. And so in all cases, we've met this with the Snowball and the Snowball Edge family. We've met these problems. So real quick, let's take a look at the portfolio. I talked about the Snowball. The Snowball's first generation. All of the Snowball devices are encrypted, fully encrypted. The data on that is encrypted with keys that, as a customer, you manage those keys. And so the chain of custody and tamper resistance is all taken into consideration and delivered as part of the service for Snowball. Then we moved into, as we talked about, the use case to need to be able to start to begin process data at the point of ingestion. We ended up with Snowball Edge, but before that, they're actually kind of simultaneously with that, we have Snowmobile. So 45-foot container, semi-tractor trailer, backed up to a data center, very large tether, plugged into the wall. And as you can imagine, there's a lot of data being transferred there. We're talking about jobs that take months to complete, but it's a lot of data. Believe it or not, this is a service that's becoming very, very popular with our customers. Customers are asking for it around the world. Can you have that shipping container shipped to our site? Now, a couple different things with that. As you can imagine, highly prized data of the customers is sitting in a shipping container that's being driven around. There are options to actually have that fully escorted with armed guards and everybody else as well. So then we get into the Snowball Edge, and we're talking about processing at the edge. Initially, what Snowball Edge was delivering was 100 terabytes of object storage, and there was some onboard compute that was reserved for some system functions. And then Greengrass was enabled and offered as an additional option to operate on the Snowball. The device has since evolved We now have two versions of it. We have a storage optimized version of the device, which actually has the largest amount of object storage, has some compute that's available for customers to run workloads. So in the storage optimized version, you have 100 terabytes, or it's actually reduced down to 80 because we're using some of the storage for block storage, but you have 24 virtual cores and 32 gig of RAM to operate. So small scale workloads, you can actually do those on a storage optimized if you need a lot of storage. The compute optimized is flipped. It's less object storage, so you're about 42 terabytes, but you have 52 virtual cores or vCPUs available to you and just over 200 gig of RAM. And so when you start to look at these as options, it's just like sizing your instance in the cloud. Are you going to be CPU and memory intensive? Are you storage intensive? What is it? You can match a Snowball device to meet your workload requirements. One thing to note is that the Snowball Edge devices are clusterable. So you can have clusters beginning with as little as 5 nodes up to 10. So you can actually cluster the object storage together and present one large pool of object storage on your network to use as you see fit. From the storage, or rather from the compute perspective, the clustering is really a function of the workload that you're operating on top of it. So if you choose to cluster, uses something that's using compute clustering, that's a function of the workload that's running on there. And so let's take a look at some of the use cases. So our customers have immediately, once we unlocked the Snowball and allowed customers to actually run EC2 instances and run their workloads on the device, we started seeing a lot of use cases popping up. So imagery processing is a pretty popular use case, as you can imagine. So at point of ingestion, we have government customers that may be doing imagery ingestion from satellites. We have movie studios at point of production where you're shooting high-resolution 4K movie on-site, begin doing processing right at the location before actually sending the stuff into the studio. And then disaster response. A disaster happens in some location, all of the infrastructure is gone, now what? And so Snowball Edge is something that we've actually been working with first responders, NGOs, and some government entities to actually help do the heavy lifting for them when it comes to infrastructure replacement, or at least an interim solution while they get things recovered. A few other use cases when you get into import data obfuscation. So you may be importing sensitive data or ingesting sensitive data, but before it actually moves to the next step in the chain, you want to actually obfuscate some of the data on the device before you take it to the next step in the process. So as you can imagine, there's a lot of different use cases. As customers keep imagining them, they keep dropping them in here. This slide could probably be 2 or 3 pages. So if we take a look at some of the characteristics of the device, we have one actually out on the show floor right now. It's at our disaster response kiosk. And now that device out there is actually one of our GPU-enabled devices. And it's running ML. It's running an ML application, a simulation application for object detection. We're actually doing streaming. This is the device that's actually out there. We're running a Snowball Edge compute optimized. These devices are their own shipping containers. They are built with tamper resistance. We have encryption at the chip level, and we actually have tamper resistance and monitoring at chip level as well. So there's a lot of capabilities here from a security aspect. When you look at these devices, one could argue that they've been designed with bad intentions in mind. And the thought there is that if you have a device loaded with all of your data, the assumption is that what happens if a bad person gets a hold of your device? What can they do? So it's been designed actually to be secure to the point of which wrong person gets their hands on the device, it's basically rendered useless. So the device is no good to those who actually have it. It's very good for those who have the keys and have the unlock codes. From a military perspective, the U.S. military and entities have been using the device, but more importantly, it's actually been through accreditations and actually checked and assessed against their different compliance requirements and tested for tamper resistance and all of the requirements that you would imagine those type of workloads would require. The thing's droppable. So I don't know if you've ever seen it, but we actually you can drop the device, runs in austere environments, but we've actually even blown them up and they continue to operate. So very rugged device, and it's something that customers cutting across all the different spectrums. So whether it's commercial operations, it could be research operations, perhaps on a ship. They want to start doing some processing of some of the data that they're collecting if they're out at sea, airborne, as you can imagine, and then also in austere environments. And so if we look at some of the features that are currently available on the product, the one that's most common everybody knows about is the S3 endpoint. So you can actually, once you unlock this device, it presents itself onto whatever your local network is as an S3 endpoint. You have the ability to actually put and get data at the S3 endpoint using the same the same coding, any of the application features or capabilities that you would do in the cloud and address an S3 endpoint. You can do that as well on this Snowball Edge. So you get the synergy between operating in the two different environments. We have an NFS file interface, so there is a storage service that can be enabled and turned on the device. So if you don't want to do puts and gets for object movement, you can actually present an NFS mount point, and then for instances that are either running on the device or on the network, can actually consume that storage location. Block storage is reserved for the EC2 instances that customers can run on there. In the case of the storage optimized has doesn't have a lot. It's not exactly the fastest storage. Our first generation of making the compute available, but the compute optimized has actually 7 terabytes of NVMe flash storage available for your block options. So from running your virtual machines and the options there, you have some pretty good choices. A couple other capabilities there. I've talked about the Greengrass and Lambda support now, and then we also have the clustering. So a couple things I'd like to call on the right is that there is the ability to do over-the-air software updates for the software on the device. That is something that customer has control of, and then also hardware encryption is enabled in these devices. Very important. So let's look at some of the use cases that we're doing in the field today. I mentioned our disaster response program. So AWS has a team of volunteers that have been trained to work with various different NGOs or humanitarian organizations that in the event of a disaster, we can actually deploy and go out and support those organizations in helping with the recovery effort. So very early on in the process, we said, it's going to be difficult to go into an island that's just been blown over by a hurricane and actually establish cloud connectivity, so what are we going to do besides providing labor? So Snowball Edge was the logical choice. We jumped right into that. And so since then, we've actually been engaging the partners, our partner channels, for some of the solutions that these first responders need these solutions in the field. So this is an opportunity for them to operate these solutions that they may be running currently in the cloud, taking them out to the edge. And you know what? Let me just actually show you an art of the possible slide to give you a sample. So if you look at the left-hand side of the screen, I know there's a lot of stuff going on here, but I'll lead you through it. If you look at the left-hand side, you have relief organizations typically have their workloads running inside of relief in their data centers, in their computer rooms, whatever it may be. The thought here and the coordination we're doing here is that the relief organizations, and I'm just using relief organizations on this chart. It could be insert whatever name, whatever organization you're talking about, would build up the catalog of services that they would need during the disaster response. All of this stuff would be built in an Amazon region, running inside of a VPC, fully configured. It can be either partially baked, unbaked, or fully baked. And what I mean by that is you can start as simple as just a base AMI, which is an operating system that you would want to install software in the field on. So you can have that delivered to the Snowball Edge. Partially baked would be you have your base operating system with perhaps some additional software components delivered on top of it. Again, you do some field deployment or field configuration. And then fully baked could be literally fire up the instance, connect to the IP address, and the software or the solution begins to do what it needs to do. And in this case, it's up to the customer, just like normal. You choose how you want to do this, but you have the solution built in advance of any of the disasters. You build a catalog of services. Now in the middle here, we have different backhaul options to the internet or to the cloud. In most cases, these things won't exist, or at least they won't exist for a little bit of time after the disaster has occurred. One of the first things that usually gets reestablished is if there's fiber ingress with the carriers in the region. They may have lost towers and stuff, but sometimes you can actually connect into those. But be that as it may, this may or may not exist. So in the concept of the deployment here, you would take that workload that you have deployed running in the cloud, and as you provision the devices and take them out to the edge, you now have the ability to operate those workloads irrespective if you have network connectivity backhaul to the region. And so we've done this. And then as we move forward, you have forward operating locations out in a disaster area. It could be, from the base camp, you could be doing aerial assessments, damage assessments, seeking out, looking for people, doing assessments on roads. Are roads passable? Before you send first responders out, you want to kind of do a little bit of advanced reconnaissance and figure out what's going on. Suburban areas, reestablishing connectivity for government entities, government operations, police function, things like that. Things to just get the communities up and running again. And one of the other services that are capabilities that is actually highly sought after in a disaster area is people want to use social media. They want to let people know that they're okay. They want to be able to have access and do things like that. So we have enablements that can come with that. And so here we have an example with We Robotics. We Robotics approached us and wanted to talk about how they can use Snowball Edge out in the field. So we did an exercise a year ago, a joint exercise with We Robotics, several humanitarian organizations, the Peruvian Air Force. We were down in Madre de Dios in Peru, in the southern basin of the Amazon rainforest, of which one of the things that they need to be able to coordinate with is they need to be able to have effective coordination with all the drone pilots when we're out doing surveillance, and also be able to take all of that data and do something with it while they're in the field. Before, it was pretty problematic where they would just use laptops and they would have to just specifically do smaller areas that they're doing exploration. They'd only have to take all the computing power for just a small piece of the area. Now that they can actually expand because they have a lot more compute. And so what we did is, working with the Air Force, they actually had three things that three main problems in that area. One was deforestation, so they wanted to be able to measure impacts, environmental impacts, things that were happening. They wanted to actually identify this is all through drone video and imagery collection. They wanted to identify illegal mining operations, which is a big problem. And then the third thing, which something I was like, I'm surprised that this actually fit into this scenario, was actually looking for human sex trafficking. Camps being set up out and about. And so this information was all being collected during the day. There were exercises, different teams were going out surveying different areas. They would bring the information back, and then we would ingest it into the Snowball Edge, which was running Esri, Drone Deploy, and a few other software tools. And then ultimately, from a flow perspective, what we have here was the mapping information would come in. We would immediately, we'd update it to the Snowball Edge device, and it came in through multiple formats. Some of it was drone feeds, different formats of drone feeds, some of it was still photography, whatever it was. We would run machine learning algorithms against that, and also mapping, build the mapping layers, and then present back. We actually had Esri, we had ArcGIS web application built so that later in the day we would actually go in with the military and we would do a daily briefing. This is what we've learned today. And then they actually set forth what were the marching orders for the next day's missions. So we would do that. So before that, all of this information, most of the time it was selective sampling on laptops. It was not always covered very well. And the information flow was very, very sparse. Now we actually were able to gather everybody, both the drone pilots and the military, and assess the information, the quality of the data that we were receiving. So another example, In Situ, which is a Boeing company, approached us about doing a proof of concept, a pilot with their aerial modeling data. And what they wanted to do was, using their Scan Eagle drone, if you would, unmanned aerial systems. So they would actually, here in Queensland, they would use these Scan Eagles to actually do inspections for wellheads in different areas, different pieces of infrastructure within the countryside. And so if you look at the old process, the way that would work, it was a very manual process where people would go out and do physical inspections. And so if you imagine you're driving for hours a day, They would go do the inspection, and then all that information would be aggregated, brought back, and then they would have to figure out if they actually had good information. By using the Scan Eagle, you're actually able to take the information, process it immediately on the ground, figure out if they actually had good quality imagery. If they had good quality information, they could quickly turn that around, and ultimately that information was being fed back up into the cloud. The picture on the right-hand side is actually some of the proprietary 3D reconstruction algorithm. This is a picture of a mine that they actually did with single-pass scan flyovers using the Scan Eagles. So all of this stuff was calculated and processed on the Snowball Edge out in the field. The last use case I'm not going to talk a lot about, but because you can imagine, probably can't talk about a lot of it, but we have use cases with the military and other organizations that have mission-oriented requirements in austere and inhospitable environments that definitely are disconnected. So this is something that we've actually had active use cases. We still have active use cases, and the amount of consumption of the resources, whether it's land-based, aerial, or sea, is continuing to increase significantly. So this is a fast and growing area of the marketplace for Snowball Edge. Now, a couple different things. At last year's reInvent, Outposts was announced. Outposts, we get a lot of questions about Outposts, and the reason why I included this in here is because people are like, well, wait a minute, Outposts is we can just take Amazon data center infrastructure and put it out into a disconnected environment and operate and have cloud. I specifically have added this into this talk because that is not what this solution is for. Outposts while it is AWS infrastructure running at a customer's location, it is intended to always be connected to the region. It is not a disconnected solution. So Snowball Edge would be your disconnected solution. Outposts would be, we need to have AWS infrastructure. We want to have it on site. It could be for low latency processing. It could be sensitive data that maybe you don't want to move into the cloud right now. Whatever the reason is, this would run inside the walls of a customer's location that they see fit. Key thing here, it's a fully managed infrastructure owned and operated by AWS. So the equipment will arrive to a customer's location fully configured. Literally, it's racks rolling into a data center, power added to it, network connectivity brought online. It actually will reach back to the region, and then the region's control plane will actually configure the stack all automatically. It brings it alive. Key thing to note about this is that Outpost is actually not a bespoke version of our control plane. It's not AWS Lite. It is actually operating the exact same management control plane that operates our regions, and that's why there's the tethering that goes back. There's a lot of heft to our management control plane. If you think of all of the security functions, the auditing functions, the API logging with CloudTrail, all of that types of capability, these are all control plane capabilities and services that are delivered just automatically now. People just kind of take them for granted. Well, you still have that capability available to you, and it's actually used for you with Outposts. And so connectivity back to the region is required. There's also a VMware Cloud variant of this, which will afford the customer the choice to be able to run VMware Cloud's managed offering on the actual Outpost in their location. So if you can imagine, the way VMware Cloud operates today is VMware operating it on behalf of a customer. It's dedicated private clusters. Those can actually extend and operate within the walls of a customer's location. So that is coming soon as well. Key things on the instances and the storage options. The instances are Nitro-based instance. And so any of our essentially instances that you can get in a .metal variant are the ones that are going to be making their way out to Outpost to include the GPU versions. The i3, we have i3 listed here. It's actually going to be the i3-EN family. We'll make it out, which is much more dense from a CPU, memory, and onboard storage. There's a lot of interest in this solution, as you can imagine. What we have are customers that are bringing use cases to us that we didn't even think about when the product was announced, which is fantastic. And so what this is affording us to do is give us the ability to give customers an option where you can run AWS where you need it. So you obviously have the region-based stuff. you have the disconnected with Snowball Edge, and then you also have a slice of AWS region capabilities delivered to a customer location. We're able to hit across the paradigm. And so many of the customers that are expressing interest in Outposts very quickly pivot into a conversation about Snowball Edge because many of them have disconnected use cases. And so part of what we're doing is an education. Sessions like this are intended not just to highlight the Snowball Edge and the disconnected nature of that, but what are the options along the paradigm. And so with that, it's time for me to wrap, and I appreciate everybody coming here after lunch. I know it's always hard to be the first session after lunch, so thanks for everybody staying awake. And I appreciate it if you guys can complete the session survey. Thanks, everybody.